few months ago, maybe you were looking at your TV or listening to the radio, looking at this guy called Felix Baumgartner, who was doing nothing than trying to skydive from the highest level of the atmosphere, right? If you had no time to watch TV, maybe you were connected on the forums, the SolidWorks blogs and forums, following, the simulation series that Steven Andersby was running, just to understand if Felix, while he was diving, he would break the sound barrier. So we thought that it was a good idea to have Steve coming on stage and explain to us what he was thinking about. So Steven, please come on stage.
Thank you, Bertrand. I first heard about the Red Bull Stratos project back in March last year. And those of you who know me would not be surprised, the first thing I did was to run a flow simulation to see if it was possible for the human being to go through the speed of sound. Now, many of you have already seen what happened on that momentous day back in October, but let's run the video and remind ourselves of what happened.
We got to get Felix off the ground safely and not tear the balloon. And we need optimum conditions. So as the weather person here, we're going to be very, very, very picky in picking the right conditions.
Felix has completed his physical.
I've been working 4 years on the program. I believe in what Felix is trying to do to test the next generation full pressure suit. And I'm just delighted to be a member of the team.
This is mission control at this time. Felix is departing his Airstream trailer to be strapped into the Stratos capsule.
I will assess the situation again. We will not start inflating as soon as the balloon's completed laying out.
Copy
so there'll be another small hold.
T-minus 1 hour, 13 minutes. We're going to go on hold.
Chuck Yeager was the first man to go supersonic in an aircraft. It was 65 years ago, and I think it would be just absolutely wonderful if we could get Felix to go supersonic without an airplane on the same day that Chuck Yeager flew supersonic in an airplane.
At this time, we have begun balloon inflation. Capsule systems are green, instrumentation's green, payload's green, medical systems are green.
There's the release, and there's the applause, a successful rise.
This is mission control. Felix's current altitude is 25,300 feet.
We're at 108,000 feet. There is an issue with the heat in the faceplate. Mission for the time being is continuing as the team considers what are the options. So the decision has been made. Baumgartner will jump.
The whole road is working out. Sometimes you have to get up really high. How small you are. I'm going home now.
Jumper away.
I think you'll agree that's a truly amazing sight. But how many people in the room know that SOLIDWORKS played its own small part in making that happen? To tell the engineering story behind the headlines, I'd like to welcome on stage Art Thompson and John Wells from Sage Aviation to let you know how we got this thing off the ground. So before we talk about the Red Bull Stratos project, are there any other projects that we might have heard about that you were involved in, Art?
Well, in the late 70s, with a group of about 14 engineers at Northrop Corporation, we conceptualized the idea and presented and designed the stealth bomber. Did a series of programs with low observable aircraft. And with one of our sister companies that we have is A to Z Effects. We did the Mini Coopers, which so many of you probably have seen, the can cars, built over 700 vehicles for Red Bull. And then movie projects such as the Batmobile and Air Force One, Contact, so different things like that.
Very, very varied projects. But the Red Bull project, first question has got to be, who thought of this idea? Where did it start?
Yeah, the original conception goes back to an amazing man. Joe Kittinger worked with the Air Force in the late 50s and 60s. The president wanted to see, could man survive at altitude? It was pre-Apollo, pre-Gemini, it was before the space program. And they wanted to know, could man go to these levels? And so the Air Force set off to put people into high-altitude scientific balloons to get them up there. Joe went up in 1960 to an altitude of 102,800 feet, where he stepped off and became the first person to free fall from that altitude. That record's held for 52 years, and it really was something that was the pinnacle of what every parachutist wanted to try and do again. And so Felix, who's a good friend of mine, knowing my background in aerospace, called me one day and said, "Art, you familiar with Joe Kittinger?" And I said, "Yes, I am." He says, if you were going to break Joe's record, how would you go about doing it? And I said, "Well, let me think about this a little bit, and I'll give you a call tomorrow." So I called up a couple friends. One of mine, Rick Searfoss, who was the shuttle commander for Columbia and Endeavour. And Rick was also the chief judge for X Prize. It was before Scale Composites had won the first phase of the X Prize with Spaceship One. And dear friend of mine, Eric Purdom. And we sat down and started conceiving the design and idea of how we would go about doing it, including the possibility of a rocket plane. And eventually jumped on a plane, flew over to Austria, and presented to Felix and Red Bull some concepts. But it had to be a flight test program. It had to be a serious scientific endeavor.
So to sum up your pitch to Felix, you basically said, "Felix, we're going to put you in a can, attach a big helium balloon to it, lift you up to the edge of space. You're going to jump out, break the sound barrier, pull a ripcord, and land safely."
Something like that, yeah.
I don't know about Felix, but I'd have taken quite a bit of convincing to actually do that.
Yeah, it had been a dream of his since the time he was a little kid. You know, growing up, looking at the astronauts and the Apollo program and all of that. And so it was something that was truly in his heart. So it took a little bit of convincing, but you know, I think as we got into some of the more safety issues, he started realizing how technical and what kind of level of problem it was and why it had to be a true flight test program.
So John, you're the designer. You know, Art's the ideas man. You've got to create his ideas into reality. So what did you think about the project when he explained it all to you?
Well, I first came on the project in 2008. It was going from napkin sketches and concept to actual physical design and layout of all the components. And I was told it'd be a 6-month program. It'd be real fun to start. And 5 years later, and over 15,000 hours of my life put into the program, we designed the components and built a flight test program. to make it a reality.
I mean, one of the things with the flight test program is it's all about safety. But surely jumping from the edge of space is inherently unsafe. I mean, how do you make it safe?
Yeah, you have to really think about the entire test program. I mean, one of the things was really bringing together a group of brilliant designers and engineers, friends of mine who I've worked with on a number of other aerospace projects that bring a lot of credibility in mind to what we're trying to create. That's really the important thing.
Okay. Now, we saw on the video the pressure suit that Felix was wearing. That looked like a pretty sophisticated piece of kit. I don't think that's in my local Walmart. Where did you find that?
Well, the inspiration of the pressure suit, the spacesuit, is really from a friend of mine, Bill Weaver, back in the 60s, 70s. He was a test pilot for SR-71s. Bill was forcibly ejected out of a SR-71, a Blackbird, one of the fastest aircraft, that came apart around him, and he was wearing a David Clark suit, and he survived an ejection out of an aircraft at Mach 3.18. So he's going over 2,100 miles an hour. Hearing that story, you know, and knowing Bill, I said, you know, that's probably the suit we need. So David Clark Company has a rich history of creating the pressure suits for the space shuttle crew escape suits, the orange suits you see, as well as the U-2 suits for the high-altitude spy planes and reconnaissance aircraft. And so David Clark, who has been having people come to them for over 40 years or 52 years, with people trying to buy these suits or use these suits, they've been telling people no on a rate of about 4 times a week. So I showed up on their door and said, you know, I'm interested in getting some spacesuits. And that took a lot of convincing to get them to understand that we were truly an aerospace group, a technical team, that we had the competence to be able to really assure that we were going to take this the next step. There's been a number of people who have died trying to break Joe's record, and so there's a big concern over liability. So being the first company to be able to purchase a spacesuit is a pretty significant thing.
I mean, John, your job was to design the capsule that Felix went up in. What was technically the most challenging part of that whole process?
Most challenging part of the process is really putting a pilot in a position I would never put myself, making sure that everything's tested out right, all the design procedures, making sure everything is done and followed through to guarantee his safety. And the life support system on it is second to none.
I mean, how many people were actually involved in the whole project from on the design side?
Well, the Sage Test team, you know, as far as engineering and staff, there's Riddell, which was communications. There's Flightline Films for the camera works, camera systems. We had a team of about probably 25 medical doctors. The direct involvement, probably about 10 doctors on the physiological side. Engineering staff was probably in total, including the launch crew and everything, about 50 people total. But the core team at Sage Cheshire that did most of the design, fab, engineering, was probably only about 12 people.
That's actually quite a small group.
Yeah, it's very small, but the nice thing is you're very efficient that way.
So in the whole program, I mean, Felix came up with the idea, but was there any point in the program that you wondered if Felix could actually do it? I mean, were there times you had doubts?
There was a big concern. What we did in the early part, in the conceptual phase, is we built a, much like all of you have done, you start with a napkin sketch, a concept, an idea, it builds into some development models. We built a plywood mock-up of the capsule that was an ergonomics model, just to kind of think through the process. That was drawn out in CAD and machined on our 5-axis mill. We built the ergonomics model, put Felix in, snuck a U-2 suit out the back door of one of the other facilities. Don't let anybody know, okay? So to get Felix in and put him in the suit to see, because there's a concern right off the bat with pilots is that when you put somebody in a spacesuit, there's this feeling of claustrophobia, being closed in. So Felix shows up thinking that he's looking and testing us for, okay, what do you guys have in mind? You know, what are we looking at here? And our group is on the other side of the room going, okay, now we're gonna see if he can handle being in the suit. So we stuck him in the suit, put him in the ergonomic model, had him sitting there. We pressurized him, so he's all inflated. And then we left him there. We walked away, and Mike Todd, our life support engineer, leans over, he says, you know, this may just work. So after deflating the suit and letting him out, and Felix was a natural, he took to it very quickly. You know, what was disturbing along the process, there was one point when we went for doing some of our testing, Felix had a breakdown where he got claustrophobic, and so we ended up having to call in groups, and Felix asked me at that point, it's like, well, what does the Air Force do if a pilot gets claustrophobic or he has a problem? How do they cure him of that? So they usually get rid of him and bring in the next guy. But Felix overcame his fears, and we eventually worked through the process and got him to altitude. And you got to admit, I mean, for somebody to step off that kind of an altitude, it
pretty
takes
intense,
a lot,
yeah.
pretty intense.
I mean, John, SolidWorks takes pride in listening to its customers and developing solutions for them. Now, Felix was your customer. So did he actually involve himself in the design process to have the things change?
Felix, with his line of work, he's a very meticulous customer. He really likes to be able to walk up and see multiple options that are all possible solution, which on our case brought up 3-4 times the amount of work and having to develop multiple options for every possible problem that we could come across. So Felix would actually come in, we'd present him with options A, B, C, and he'd decide which one would work best for him. And then from there, we'd move on to the next problem, the next set of solutions, and progress forward with the program.
I mean, Art, you talked about this as being a flight test program. I mean, what did NASA think about this?
NASA at first, when we first came to NASA and talked about the ideas, were incredibly excited. You know, the technical team looked at it and said, this is what we lived to do in the 60s and 70s. It represented everything that the space program was. So they were really excited about it. But then when you start getting the attorneys involved and the bureaucracy and everything else, and they start thinking liability, and I don't know what happens if something goes wrong, and we're involved and our name's attached. And so because of that, there was a big resistance, which was okay in the long run, because what we ended up doing at Sage Tischer Aerospace, we ended up developing and creating a lot of the things ourselves, or figuring out what the solutions were on our own. By the time we finished, NASA, of course, came back around and said, you know, but by then we were already past that point, so it's okay, well, we can have you participate and watch the programs and stuff. And so it was really a challenge to overcome a lot of the bureaucracy and issues.
So the whole project was as much a feat of engineering as defeating the evil bureaucracy.
Yeah, definitely overcoming bureaucracy and trying to keep it as simple as possible.
I mean, one of the questions I've always thought about, if I was to go up there, that I'd never go up there, but what if something went wrong? I mean, we're in a capsule, I'm a spacesuit, what if both things fail? What would happen to me?
Well, at altitude with atmospheric pressure, when you get up to about 60,000 feet, 61,000 feet, is something called the Armstrong line. Not to be confused with Neil Armstrong, but Dr. Armstrong had discovered that at a certain altitude, there's enough atmospheric pressure to hold the gases in your blood in suspension. Once you get beyond that, the oxygen and all the gases that are in your bloodstream start to escape. They want to come out of suspension. And so if you had a failure of the pressure suit, if you had a failure of the capsule itself at altitude above 60,000 feet, it would be like taking a box of Pop Rocks and sticking it in your mouth. It would start to fuzz, fizzle, and bubble in your mouth. And then it would start to ooze from your eyes, your ears, your nose. Your body would inflate to be about twice the size. And so it's very painful process.
A good job it didn't happen. The Red Bull project was quite a long, drawn-out project and a very high pressure. I mean, what did you do to relieve the pressure for the team?
Well, people who know me know I like to do a lot of crazy things and think outside of the box. Just a few. And get involved in people come with projects and ideas that seem a little bit nuts, and I usually say, yeah, we can do that. So in the process of doing Red Bull Stratos, while we were preparing for Manned Flight 1 to go to 71,000 feet, Pima Air and Space Museum had come to me and said that they wanted to build a paper airplane. So we ended up building the world's largest paper airplane. It was 45.5 feet long, had a wingspan of 24 feet, all paper. We launched it from a Sikorsky S-58T helicopter of an altitude of about 1,400 feet. It flew just short of a mile, got up to about 98 miles an hour in free fall in flight. Actually was removing parts of the flight surfaces. And definitely set some new records there. But that was 6 days after Manned Flight 1.
So not only did he ask you to actually make this capsule, John, he also gave you a nice little side project.
Yeah, a nice weekend project, something that would motivate kids of possibilities that they could do large projects in the future.
Next generation.
It was a fun weekend gig after doing a very intense Manned Flight 1.
Yeah. So we all, like I say, we saw what happened up until the point that Felix jumped off the capsule. Let's have a quick look at what happened after that.
I'm going over.
Jumper away. Speed 650 miles per hour. Speed 725. Speed 729. Felix in a stable descent. Felix is back to land safely, the new world record holder.
When you're standing out there on that step, on top of the world, you know, you become so humble. At that moment, it's not about breaking records anymore.
Amazing. Now, I saw you in the video there, sitting front of in the control room. I mean, how was it that day? How did you feel?
It's definitely intense. It's like having a 5-year baby. You know, it's Felix. You know, you build up and all the engineering, the design. You know what all of you do. I mean, you live this every day. You see your projects grow from a creation, a concept. It builds into more and more until finally you get to see this finished product. I mean, that is our finished product. That is what we did. And having control over all this, we go through all this over and over routine of testing and developing and training, the 47-point list of egress, of getting out of the capsule. It all comes down to the launch, where you have absolutely no control of what the weather and the wind is going to do, what the conditions are going to be as it comes up. And so it's definitely a great feeling to see that come up and launch. The balloon itself is 750 feet tall. And to put that in perspective, the Eiffel Tower is about 1,000 feet, so it's 3/4 the height of the Eiffel Tower. The Saturn V rocket that put the Apollo on the moon is 360 feet, so it's almost twice as big as the Saturn V rocket. So it's quite a feat to see that thing come up and feel that once it's up in the air and it's like, okay, he's on his way, you know, now I have to worry about when he steps off, so.
John, where were you on that day? I mean, how did you follow the system, and when did you know he'd broken the sound barrier?
For me, I got to enjoy not just going from production and design all the way through testing, but to be there and see all of your work that you put into a program for over 5 years and see live on phones that yes, he has jumped, hearing over the radio calls that yes, he has jumped, standing 23 miles or so directly below him and going, he should be going supersonic. And as you're thinking that, hearing for the first time ever created by a human body without a vehicle, a sonic boom, and it was heard by 20 people, recorded by one audio device, and for years we debated if it would ever be able to hear it. Such a small object traveling so fast, so far away in such thin atmosphere, and everyone on the ground heard boom, boom, a double sonic boom for the first time, and everyone looked around going, is that really what we think it was? We had to review it multiple times to assure ourselves that's what we heard.
Exciting.
Yeah. I mean, this was a flight test program. I mean, what did you learn from the jump, just beyond supersonic?
The big things we're going to learn from it, and it really had to be a flight test program. I mean, the entire team, Red Bull, I made it very clear, and they finally got it as we're in the midst of it, that it was a flight test program, that it was complete with testing and development of the systems. What we developed is the next generation spacesuit. It's what David Clark will use to develop the Orion suit. Higher mobility, higher flexibility, egress from high altitude, trying to learn what the body does during those phases. We measured and collected an incredible amount of data from accelerometers and GPS. Felix had 4 GPS systems on him. The capsule had 3 accelerometers. There's a lot of technology that's going to go into the private space program and hopefully benefit the safety systems and thinking in terms of where we're going in the future.
So one last question. What happened to the capsule, and has everyone phoned you up asking to borrow it?
Yeah, the capsule, part of the design process is how do you land a 3,000-pound object on the ground safely? The design of you know, a lot of the landing systems, the crush pads, the capsule, the way the ergonomics of the egg itself, the pressure sphere with the frame and the crush pad area, allowed us to recoup that capsule for all 3 flights. We used the same internal guts for all 3 flights, the parachute systems and recovery, and the capsule actually landed on manned flight 3 in perfect condition. It is going on a tour, museum tour around the United States, and its eventual home where it's going to end up is in the main hall of the Smithsonian, which is kind of exciting. There have been people calling immediately afterwards, and can you do the same thing, and can we go higher? And there's definitely ways of going higher. There's a limitation to where you can actually go with a helium balloon, scientific balloon, as far as altitude, and we're pretty much there. We're right at the altitudes. But as you continue to go up, the complexities increase, the logistics increase, the danger of a flat spin roll in conditions, and so it's hard to say where it's going to go.
Well, Art, John, thank you so much for coming. It's great to see you. Thank you.
Pleasure. Thanks.
Thank you.
Congratulations. Congratulations.
Thank you for having me.
It's a pleasure.
Really enjoyed it. Thank you.
Amazing, huh? This is the engineering team. You know, I was thinking, you know, look, we do cardboard bike. Now we do paper plane. So I don't know, there is clearly no limits, right? Well, thank you. And I was also discussing with Bernard, you know, looking at all that, and we said, that's really a 3D experience, right? When you dive like that and you move in 3D, so great, fantastic, thank you. With that, it's now time to close this session. So on behalf of the entire SolidWorks team, the resellers, the partners, I would like to thank you really to be with us today. Thank you for this great session and have a great day. See you tomorrow.